My dear future civil servants, welcome to the third class of Daily CSAT 2025 series presented by Connect Learner App. I am Sachin Gopanaal. This is an initiative where we will be discussing previous year based CSAT questions and concepts with an angle to make you prepared for the CSAT paper of 2025 year. Let's go to the first question where we will be learning basic concept. And based on that basic concept, we will build one concept on another and will gradually rise up to exam level questions by the end of this class. Okay, this is the first question where you will be learning one basic concept based on which a previous year question it had appeared in the paper, and based on that you shall get a homework question which is one step ahead of the question that was asked in the CSAT paper. Okay, now let's take a look at this question. If a cube is to be cut into n number of identical pieces where the number n is a perfect cube. What is a perfect cube? The numbers 1, then 8, then 1, 8, 27, 64, 125. These are perfect cubes. That is 1 into 1 into 1. 1 into 1 into 1. We will represent it as 1 cube and its value is 1. 2 into 2 into 2. Its value, it would be represented as 2 cube, its value would be 8. 3 into 3 into 3, it will be represented as 3 cube and its value is 27. So these numbers 1, 8, 27, these are called perfect cubes. If a cube is to be cut into n number of identical pieces, what does the word identical mean? It means exactly same, where the number n is a perfect cube with minimum number of straight cuts, that is straight cut. What will be the shape of those n identical pieces? Let's understand the question first. Before going to that, we shall understand what this cube is. This cube we understood, a number perfect cube we understood. These are perfect cube numbers. What is this other cube? What is cube cutting? Cube is a three-dimensional geometrical figure. This is the structure of cube. It looks like this in 3 dimensions. Ignore these cuts. Ignore this, they're just animation. This is how the cube looks. In the real life, where do we see cubes? For example, dice. Dice is a cube. Then Rubik's cube, that is a cube. So this is the structure of a cube. A cube, it is formed by 6 identical square faces. By joining 6 identical square faces, we get a cube. This is how a cube looks in 3 dimensions. Okay, this is a cube. Then the question is asking us, if a cube is to be cut into n number of identical pieces. Okay, we shall cut a cube into n number of identical pieces where n itself is a perfect cube. Then what will be the shape of those identical pieces? Okay, just remember this one. Take it as a rule. If a cube is cut into n number of identical pieces where n is a perfect cube, then each of those identical piece, they would also be a cube. Just take it as a rule, take it down in your notebook. If a bigger cube, it is cut into n number of identical smaller pieces, each of those small pieces would be, they themselves would be cubes. Then it will not be a cuboid, it will not be prism, it will not be triangle prism. The key term, the key point here is with minimum number of straight cuts. If it is any number of straight cuts, then it can be this thing also, other geometrical figure also. It can be cuboid. That is possible. But when they are cutting it into identical pieces with minimum number of straight cuts, each of them they will be cube. Just take it as a rule. Okay, done. Sir, based on this concept, now we will build the higher level questions. If a cube is to be cut into 8 smaller identical cubes, what is the minimum number of cubes? What is the minimum number of cuts required? Now, we learned what a cube is. This is a cube, right? And now they want us to cut it into smaller cubes. For example, this one cube, they want to cut it into multiple pieces. How many pieces do they want it to cut into? They want 8 smaller identical pieces. So one cube, they want to cut it in 3 dimensions into 8 identical pieces. What is the minimum number of cuts required? If a bigger cube, it is to be cut to get smaller identical cubes, then what is the number of cuts required? You can take as many cuts, right? If you can cut it in, imagine a cube, for example, cubical shaped cake or something smooth, a sponge, something you can cut it. If you can cut it into 8 identical pieces, you can take many cuts, 5 cuts, 6 cuts, 7 cuts. I don't know. There might be multiple ways to cut it. However, they want us to use minimum number of cuts. So what is the minimum number of cuts required to cut a cube into smaller pieces? So there is a ready formula for that. What is the formula? Cube root of n minus 1 into 3. What is cube root of n? These are the cube numbers. 1 cube is 1, 2 cube is 8, 3 cube is 27. So similar way, the cube root of 27, that would be 3. Cube root of 8, that would be 2. It is just the converse of it. So cube root of 64, that would be 4. Cube root of 125, that would be 5. So just the converse. Cube root is the opposite of cube root. So if 9 cube is 729, then cube root of 729 is 9. So that is cube root. So if you want n number of identical pieces, in this case it is 8. N's value is 8. So the formula is cube root of n minus 1 into 3. We shall just use the formula directly. Cube root of 8 minus 1 into 3. What is cube root of 8? We know that cube root of 8 is 2. So that would be 2 minus 1 into 3. What is 2 minus 1 into 3? That would be 1 into 3, and the answer is 3. So the answer to this question is 3. Okay. Now, based on the two concepts that we learned, what was the first concept? If you are to cut a cube into n number of smaller identical pieces, where n is a perfect cube number and you want minimum number of cuts, then each of those smaller identical pieces, they will be cubes. That is the first concept that we learned in the first problem. And in the second problem, we learned that if a cube is to be cut into smaller cubes, identical cubes with minimum number of cuts, that would be given by the formula cube root of n minus 1 into 3. Okay, based on these two concepts, we will go to next question, where we will apply the two concepts that we learned in the previous problem. If a cube is to be cut into 27 identical pieces with straight cuts, what is the minimum number of cuts required? What is the difference between the previous problem and this one? In the previous problem, they told us that they wanted to cut a cube into 8 smaller identical cubes. So they had readily mentioned that they wanted smaller cubes. But in this one, they're telling us identical pieces. They have not mentioned cubes. However, using the first concept that we learned, what was the first concept that we learned? The first concept that we learned was this one, right? If you are to cut a bigger cube into n number of identical pieces with minimum number of cuts, then each of those shape, that will be cube itself. So here, even though they have told us identical pieces, we can consider them to be identical cubes. Why? Because they have told us minimum number of cuts required. So what is the minimum number of cuts? When the minimum number of cuts is required, each of those identical pieces, they will be cubes themselves. So that is the concept that we learned in the first problem, and we will use that concept here. And now we have a formula for this one. The formula is this one, right? If you are to cut a bigger cube into smaller cubes, then the formula is cube root of n minus 1, cube root of n minus 1 into 3. What is cube root of n? In this context, the n value is 27. So cube root of 27 minus 1 into 3. What is cube root of 27? It is 3. 3 minus 1 into 3. So 3 minus 1 is 2 into 3. That would be 6. So your answer is 6 cuts are required to cut a bigger cube into 27 identical smaller pieces, because each of those smaller pieces, they will be cubes themselves, and we have a formula for cutting a bigger cube into smaller cubes, that is cube root of n minus 1 into 3. So your answer would be 6. Okay. Now based on this, we will just go to our next question. Same concept, no much difficulty, just the number gets bigger. This was asked in the 24 paper, CSAT 24 paper. What is the least possible number of cuts required to cut a cube into 24 identical pieces? We know that when they ask us to cut a cube into identical pieces with least possible number of cuts, then each of those little pieces, they will also be cubes themselves, and we have a formula to get the cuts required to get identical cubes. That would be cube root of n minus 1 into 3. Apply this formula. What do we get? Cube root of 64 minus 1 into 3. What is cube root of 64? That would be 4 minus 1 into 3. What is 4 minus 1? That would be 3. 3 into 3. So that would be 9. Your answer is 9. So 9 cuts are required. The 9 is the least number of cuts required to cut a cube into 64 identical pieces. So based on this, we will learn, we will solve a homework question. This will be your homework question. Same concept, same logic. However, it is an application based one. In a school, a large cube-shaped cake is to be cut by teachers and distributed equally among the children of 5 classrooms with an average strength of 25, such that one teacher can make only one cut. What is the minimum number of teachers required to cut the cake? Okay, let's understand the question. The question says that there is a big cube-shaped cake. Okay. Now, they are to distribute it among 5 classrooms, and the average strength of each of those 5 classrooms is, average strength of all the 5 classrooms is 25. And the condition here is that if a teacher comes, he can make only one cut. And if the next teacher, she can make another cut. So no teacher can make 2 cuts. Each teacher, they can make only one cut. And they want minimum number of teachers involved. So what is the minimum number of cuts that they can make? Here, in the previous problems, we had readily, we knew how many cuts, how many little cubes we wanted. Here also it is cubes. We have to cut the large cube-shaped cake into little cubes, little cubicle shaped pieces of cakes. However, they have not given us the exact number. What is the exact number of students? They have told us that there are 5 classrooms, and the average of those 5 classrooms is, and the average strength of those 5 classrooms is 25. Using this, we need to calculate what is the total strength of the students in that school. Use this formula. Average is equal to total divided by number of items. The average is 25. The total is total would be give us the total strength of the school. The number of items, that would be 5, because there are 5 classrooms. So put 25 here, put 5 here, then you will get the total strength of the school. That is how many children are there. Then take that number of to be the number of cuts, the number of little cubes that you require, and apply the formula. Which formula? Cube root of n minus 1 into 3. Apply this one, and that is the minimum number of cuts required. Since one teacher can make only one cut, that is the number of teachers that we will require. Do solve this one and leave your answers in the comment section. We will discuss the answer to this question in the tomorrow's class. Okay. Now we shall discuss the answer to yesterday's homework question. This was your homework question. It was based on the concept of board mass 5 star 4 star 3 star 2 star 1. In this expression, star is chosen from plus minus into each at most 2 times, but none consecutively. It means instead of star, for our convenience, we will write dash. So this is the mathematical expression 5 dash 4 dash 3 dash 2 dash 1, and we are to fill these dashes with plus, minus or into each operator plus minus into, it can be filled 2 times, but it cannot be filled consecutively. That is, if you use plus here, it cannot be plus here. If you use minus here, it cannot be minus here. If you used into here, this cannot be into. So it cannot be consecutive. If it is plus, this can be plus or this can be plus, but not this one, because they cannot come consecutively. And they want what is the greatest value of the expression. This question, it is just one step ahead of the CSAT level paper, CSAT level question. Okay. Now we will use our basic logic that we learnt in yesterday's class to solve this one. Okay, we want a greatest expression, right? We want the greatest one. What are the operators that we have? We have plus, minus, and into. And how many places, how many spots do we have? We have 4 spots. So plus, minus, and into, we can use each operator twice. So we shall not use this minus at all. Why? Because minus will always decrease the value of the expression. 5 minus 4, that will give you 1. 4 minus 3, that will give you 1. 2 minus 1, that will give you 1. So anything minus anything, that will always lessen the value of the expression. So we will not use this minus at all. We shall use only plus and intos. Okay, how? There are only 2 possible combinations. You might think that there are multiple. There are only 2. I will tell you how. Let's try putting plus here. If you put plus here, then you are forced to put into here, because we have decided not to use minus. So if it is plus here, it cannot be plus here. So it is into. If it is into, then you can use only plus here, because it is into, you cannot use into again. Then we are left with another into. Yes. So 5 plus 4 into 3 plus 2 into 1. This is one possibility. The other possibility is 5 into 4 plus 3, because you have used into here, you cannot use into here. We can use plus, and we have already decided that we will not use minus. Since it is plus, we cannot use plus here. We are forced to use into. And now we can use plus again, because it is not consecutive now. Yes. So these are the only 2 possibilities that are possible. Okay. Now we will solve them both and we'll get the answer. As per our board mass rule, we need to do multiplications first. So what will this give us? 5 plus 12 plus 2. And what will this give us? Again, as per our board mass rule, we need to do multiplication first. So this will give us 20 plus 6 plus 1. So 5 plus 12 plus 2, that will give you the value 19. And 20 plus 6 plus 1, that will give you the value 27. So of these 2, which is the greatest? 27 is the greatest. So your answer will be 27. Okay. This looked a bit difficult when you looked at the, when you try to solve it yesterday, it might have seemed difficult. However, this was an easy level, it was easy to solve if you understood the logic behind it. This is how your UPSC has been framing questions in CSAT. It will take very basic level concept and it will apply one just a layer upon the previously year asked a question. Then they frame one such question. Okay. Do understand the concepts behind the questions. Do not mug up the questions themselves. Do understand the concepts behind them. Okay. Now, as I have already told you yesterday, we are launching CSAT course. I think we will be uploading one class each day from 1st of March to 30th of April. Do subscribe to it. The course is very reasonably priced and it will cover all the concepts that are necessary to qualify the CSAT paper. I hope that you like today's class. All the best, and most of all, I wish you a very happy studying.